Good morning. The mechanical investigation examined factors and conditions that contributed to the wheel climb. The investigation focused on WMATA's wheel touring procedures, quality assurance procedures, and interdepartmental coordination. Depending on passenger load and rail surface condition, precipitation, dew, ice, blowing leaves, grease, or other contamination, wheel slips or slides may occur and flat spots result. Consequently, car wheels generally are trued or reprofiled for flat spots rather than for wheel wear. The wheels on the fifth car had been trued 2 days prior to the derailment using a milling machine, and the car had been returned to train service the day of the accident. The wheel surfaces of the derailed car displayed a fish scale appearance that is typical of wheels trued by milling operations. This photograph shows the wheel surface from car 5152 with the fish scale appearance evident across the wheel surface. Pronounced ridges were also evident across the wheel tread as indicated by the arrows. Completely through the throat area and up the entire inboard vertical surface of the flange. The only smooth, polished area was about a 1/4 inch wide line in the center where the wheel tread most frequently made contact with the railhead. WMATA milling machine operators did not polish wheel surfaces after truing operations. After wheels were cut, the machine operator coated the wheel flange with a lubricant, which was intended to prevent the newly cut surface from grabbing into a rail and climbing to the derailment. WMATA acknowledged that the milling machine surface, which was rougher than a lathe machine surface, might be more susceptible to wheel climb, a phenomenon known to the transit industry. Transit industry research, such as Transit Cooperative Research Program Report 71, indicates that a rough wheel surface finish from wheel touring increases the probability of a wheel climb derailment. Research further indicates that wheel surface conditions may be improved by addressing the final wheel surface. Addressing the final wheel surface can involve a light finishing cut with no significant material removed to smooth the roughness of the wheel tread. Newly trued wheel surfaces can also be polished by running the cars through curved yard tracks and turnouts until the rough finish is smoothed over the entire tread surface. As an example, San Francisco's Bay Area Rapid Transit System, that's BART, uses passenger cars similar to the 5000 series cars used by WMATA. BART polishes newly milled wheel surfaces by running their cars through curved yard tracks until the wheel surfaces are smooth across the entire tread. WMATA does not have a formal process to smooth wheel surfaces after being milled. Rather, the cars with the newly trued wheels are placed in revenue service with the anticipation that the wheel surface will be polished through normal operations. WMATA has no explicit guidelines concerning the final surface texture. The draft report concludes that WMATA's lack of measures to smooth wheel surfaces after truing increases the potential for a wheel climb derailment. The draft report includes a recommendation to address this issue. The investigation found irregularities in the dimensions of recently trued wheels at WMATA, including the wheels that derailed in this accident. Although the overall profile of the wheel was accurate, measurements indicate that more material was being removed during the truing operation than was necessary. The investigators noted the wheels on the right side of the derailed car 5152 and the front truck of car 5153 had about 1/16 inch of wear, even though the wheels on both cars had been trued just days before the accident. Typically, the wear limits are between 3/8 and 1/2 inch from a new wheel to a condemnable wheel. Investigators examined the milling machine used to mill the wheels on car 5152. The cutting head on the milling machine was found to be out of alignment. The milling machine's internal bearings were replaced and the alignment was corrected. Investigators observed the wheels on a car being trued with the milling machine. Before beginning the milling operation, the machine operator did not index the cutting heads to ensure that the wheel profile would be milled correctly. WMATA did not have a standard schedule for indexing the heads. Instead, indexing was done on an as-needed basis. Transit industry research indicates that the wheel surface conditions are improved by frequently inspecting the cutting tools, especially on wheel milling machines. From discussions, investigators also learned that BART requires its milling machines to be indexed every day. The draft report concludes that although the misalignment of the milling machine used on WMATA's wheel truing operation would not have contributed to the wheel climb, it does indicate inadequacies in WMATA's quality assurance process. The draft report includes a recommendation to address this issue. Problems with the car leveling system on the 5000 series cars were identified soon after WMATA began taking delivery of the cars in 2001. As a temporary measure, WMATA created a new leveling procedure. In addition, WMATA replaced the linkage between the truck and the valve with a different design. Despite these efforts, the car leveling issue has not been resolved. The modifications did not resolve the situation, so replacement valves were considered. An American Public Transportation Association, APTA, technical review panel was convened in October of 2006 at the request of WMATA to review 7 prior derailments that involved 5000 series cars. Mr. Hipskin will discuss this further in his presentation. The panel found that up to 98% of the fleet of 5000 series cars failed a car leveling check that was made during routine preventative maintenance procedures. The panel expressed concern that the same leveling valve in the 5000 series cars was also specified in the new 6000 series cars. The panel stated that the car maintenance personnel input was either not solicited or not listened to by the vehicle engineering personnel during the design and engineering process for new cars, and there was no comprehensive process to include all relevant departments in the specification review process for new cars and equipment. The leveling valve and associated linkage from the derailed car were damaged in the accident and could not be tested after the accident. The extent to which the leveling system and/or valves may be a factor that increase the possibility of a wheel climb derailment could not be determined in this accident. Inadequate communication between car maintenance department personnel and vehicle engineering design personnel may have delayed bringing it to resolution. In the meantime, WMATA has taken delivery of more than 100 new 1000 series cars with the same car leveling system as in the 5000 series cars. WMATA is in the process of preparing design specifications for a new 7000 series car with the unresolved issues still associated with these valves. Although WMATA has now instrumented some 5000 series cars to capture data it believes will be helpful. After requesting reviews by industry experts and funding research work, WMATA failed to effectively address the proposed safety recommendations before this accident. Staff has proposed a recommendation to address this issue in the draft report. This concludes my presentation. Staff has